Well, everyone, if you can put your video cameras on, we'd love to see you. Of course, might not be possible, but this is meant to be a really intimate, interactive tech talk. You guys know we've been doing these tech talks as webinars, but we wanted to do something a bit different. Actually, LOGG had the idea, and it was so fantastic just to showcase some early career researchers in this space. And so we've got like 6 fabulous, incredible early career researchers. We're really excited to hear from them, and they're all themed around this topic of algorithms and decision making. So for those of you who don't know me, I am Juliana Schroeder, and I'm a professor at Berkeley and the co-director of the Psychotech Institute. And Nate is just sharing some slides with you, so you can put it in slideshow if you want, Nate, so you can see kind of what the agenda is, and he'll walk you through these. Okay. Nate, you're on mute. You're on mute.
There we go.
There you go.
Thank you. This is why we have co-directors of the Institute, but I'm Nate, the other co-director of the Institute and Prof at USC. It's so wonderful to see all of you here, and we're so excited about the researchers that we have who are going to be giving talks. So we have, here's the lineup of speakers that we have that we're very excited to hear from. All of them are very promising scholars in this area, and so you're in for a treat in terms of the talks that they'll be giving. So each, and this is the agenda for today. So we kind of have like a minute by minute agenda, and each talk is going to be 6 minutes. At the end of the 6-minute mark, Hannah, who has helped organize this, is going to give a ding. And so if you hear a big ding at 6 minutes, don't be alarmed. That's just her letting the speaker know that that the 6 minutes is up, and then we'll have time for a couple questions and move through to the next speaker. Then at the end, Juliana and I will lead a additional kind of 10-minute discussion if we can, if we have time there, and then we'll go to the virtual roundtable discussions. And so just as a heads up, you're going to be asked to, let's see here. So these are the roundtable discussions that we'll have after the talks, and you're going to be changing your name to put a 1 in front of it, or a 2 in front of it, or a 3 in front of it. So if you already know which of these roundtables you want to be a part of, you change your name now and just put a 1, 2, or 3 in front of your name. Or at the very end, you can do that as well, and then we'll organize you into the breakout rooms. So I think that's it for the logistics.
Great, and we have some Psychotech Institute team members here with us. In particular, let me just give a shout out to Hannah. Hannah, do you want to say hi to everyone? There, she raised her hand. Okay, there she is.
What's up, everyone?
She is going to be our timekeeper. Very important role right there. So at the 6-minute mark, she has a.
Should I make the sound? I'll make the sound. It'll sound like this.
That's the sound that you will hear. It's okay. So if you hear that, don't be surprised. That's just Hannah.
Yeah, I'll do it louder next time.
Perfect. Okay, so let's go ahead and get started. We're starting with Heather Yang from MIT, who, in case you haven't already seen her incredible work, she's on the job market. So, okay, we're excited to hear from you, Heather. Take it away.
Hi, thanks so much, Juliana. Thanks, Nate, for having me as well. I'm so excited to share with you some work that is a portion of my dissertation, joint work with Renee Gosselin at MIT. I'm a PhD candidate at MIT Sloan School of Management, and this project is examining who is more likely to resist or engage with algorithmic advice. So let's imagine the situation of Joe, the warehouse manager. Joe is a manager at a distribution facility for a popular e-tailer that you're very familiar with. And Joe's company has invested millions of dollars on developing an algorithmic advisor that can help predict how many orders he's likely to have to fill that day. So since Joe's a quick thinker and he relies on his intuition based on his many years of experience, he decides to ignore the advice of this algorithm and just go with his gut. This leads to a huge pileup of the orders that the algorithm had correctly predicted, resulting in angry customers and a loss of reputation for the company. So this scenario is one that plays out across every day, across multiple industries, and is not just limited to inventory management. So these include financial investing, employee hiring, loan applications, as well as who's granted bail. So although these technologies have made huge strides in the usefulness and proliferation, value is left on the table by users who resist this technology. Understanding the people that use these new technologies is as important as the technologies themselves in helping organizations achieve a successful digital transformation. So prior work in the literature has identified aspects of the algorithm itself that generate algorithmic aversion or appreciation. These include aspects such as the algorithm's speed, accuracy, personalization, like Carrie's work with Chiara Longoni, malleability, transparency, like Mike is going to touch on today, and the domain area that it's being used in. These works do a fantastic job at outlining the conditions in which people will generally respond to a particular kind of algorithm. But much less is known about the people themselves who might seek out or even resist this new technology. Thus, the next frontier in this space of algorithmic aversion lies in understanding traits of the users themselves. So integrating the research on cognitive reflection with algorithms, my co-author and I sought to answer the research question of when and why individuals appreciate algorithms. When we look at pop culture for clues, we see that there's no shortage of the sci-fi trope of an AI takeover with evil robots ruthlessly taking over humanity. And although the deep intelligence required for sentient agents to rule humankind is far from development, a strong mistrust still exists against novel algorithmic technology. Some individuals may be more prone to accepting these urban legends than others. This relevant trait is cognitive style, the individual tendency towards relying on either system 1 or system 2 thought processes, and it ranges from intuitive to deliberative. Intuitive individuals are more susceptible to conspiracy theories, are less likely to trust in science, and to use less probabilities in their judgments. Intuitive individuals are generally less likely to suppress biases, unlike their deliberative counterparts. So in order to test this and to see whether there was a relationship between cognitive style and algorithmic aversion, my co-author and I ran a series of studies that investigated this relationship. In the interest of time, I'll be sharing with you a very quick summary of the subset of 11 studies that we've run so far. But across all studies, the relationship is robust and consistent. You can read more about our exclusion criteria and our paradigm in this exemplar pre-registration linked here below for study 3A. So participants, basically, we recruited participants on Amazon's Mechanical Turk, and we asked them to do the cognitive reflection test, as well as to imagine themselves in a financial investment scenario in which they have to decide between 2 advisors. Then they filled out demographic post-survey questionnaires after they chose between an algorithmic and human advisor. To give you a really quick recap, the cognitive reflection test is the predominant way of measuring cognitive style. It's 3 questions that have an intuitive but incorrect your answer. So what did we find? We found that, those were the example questions, that greater deliberative thinking was related to an increased preference for algorithmic advice. This relationship was robust even after controlling for relevant factors like prior experience with AI, comfort with technology, social anxiety, the big 5 personality traits, as well as the self-reported confidence in financial literacy. This relationship was robust, even with and without controlling for demographic variables such as age, gender, political affiliation, annual household income, education, and much more. So after we had robustly connected intuitive thinking with greater algorithmic aversion, we wondered whether this relationship would hold even across different decision-making areas. So we randomly assigned participants in study 2 to one of 4 decision-making areas, such as healthcare management, college admissions, as well as employee hiring. What we found was that the relationship was robust across all the decision-making areas. The only difference being that individuals in the healthcare decision scenario were much less likely to want advice from an algorithm in general. However, more deliberative individuals still preferred a greater amount of advice compared to intuitive individuals in the same decision domain. So we're really interested in understanding why this was the case. And so we looked at the data from over 1,000 participants of open-ended text responses for their justifications for their preference. What we found was a recurrent pattern of a theme of accuracy, where some individuals believed that the technology simply wasn't there with algorithmic advisors to produce adequate results, whereas others pointed to the greater processing power and the predictive abilities of algorithms in generating more accurate conclusions. Thus, we asked participants in study 3 to share with us their perceptions of the advisors in general. We asked them about the perceptions of accuracy, and to ensure that there wasn't a post hoc rationalization for their choice, we also collected perceptions of objectivity and impartiality as well. We found that intuitive individuals actually believe that human advisors are more accurate than their algorithmic counterparts. This was in sharp contrast to what the deliberative individuals believed, where they believed the opposite, with algorithmic advisors being perceived as more accurate than the human counterparts. Just to quickly sum up, we subjected the data to a multiple mediation model where with accuracy, objectivity, partially mediating the relationship between cognitive style and advisor choice, but not impartiality. And following Preacher and Hayes' 2004 paper, we subjected this relationship to a 10,000 bootstrap samples and found that the accuracy mediated almost 35% of the variance between intuitive style and algorithmic aversion. So to sum, we found a strong and robust relationship, a strongly robust relationship between cognitive style, where cognitively reflective individuals prefer greater advice from human as opposed to algorithmic, cognitively reflective individuals prefer a greater amount of advice from algorithmic as opposed to human advisors, and this relationship being mediated by their perceptions of accuracy. This discovery is consequential in that it could preclude intuitive users from seeking out useful advice that could lead to more accurate decisions, be it managing their retirement savings or making the right hiring choice for their organization. So thank you for your attention, and I welcome your questions and feedback.
All right. Well, thank you very much. We should all clap. Thank you, Heather. So I think we have maybe time for one question as we're moving to the next talk. And I think that there's some really interesting questions in the chat. Actually, Don, you mentioned, can you talk about the correlates of intuitive versus deliberative style? So to what degree is that correlated with educational attainment and things like that? I wonder if you could touch on that, and then we'll revisit, we'll come back to discussion after that. But could you give us a quick answer to that question?
Sure, absolutely. Don, that's a great question. And even after controlling for education, the relationships between cognitive style and algorithmic appreciation is robust. And so although cognitive style is generally seen as maybe the modern day version of an intelligence quiz, a measure of intelligence, there are still aspects of access to education that relies on cultural capital, as well as access to resources and other things that are not necessarily make education and intelligence one-for-one. So, but that's a great point. And even after we control for education, we still find the effect.
Very good. Okay. Well, thank you very much, Heather. And there's some other questions in the chat. You can kind of engage in the chat as well. So like we're all open to, that's one of the benefits of Zoom. We can kind of have some of those conversations as we're going. So next up is Jen LOGG, who will be talking about algorithmic hiring. So welcome, Jen.
Great. Heather, that was wonderful. I have so many follow-up questions. Can you all see my slides? Great. So hi, I'm Jen LOGG. I'm an assistant professor at Georgetown, and I'm really looking forward to sharing work on algorithmic hiring that I'm doing in collaboration with Kathy Tinsley. So organizations use algorithms for lots of different decisions, including hiring promising applicants. The issue is that while many organizations are already investing in algorithms, especially to make hiring decisions, it's pretty unclear how applicants themselves respond to algorithmic hiring. You can imagine that at least when the labor market becomes tight again, if people don't want to be hired by an algorithm, they might even forego applying to that job in the first place. So my research tests whether applicants prefer to have their performance assessed by a person or an algorithm. In study 1, I'll test if people prefer a person to an algorithm to have their application packet reviewed for a role that they're applying to. As kind of foreshadowing a spoiler, a whopping 70% of applicants choose a person over an algorithm. This effect is robust, but we do find important factors that weaken and even reverse it. So competition of the applicant pool itself does weaken this preference for people. And we find a reversal of our effect when the hiring manager is a member of the participant or the applicant's outgroup. And then finally, we wanted to know, how good does an algorithm actually have to be before people prefer it to a person in assessing their performance? The answer is pretty accurate, 75% in fact. So in the multiple studies that I'll be sharing today, I have used a similar paradigm across all of them. So I'm going to take a little bit of time to go in detail, into detail in this paradigm here. So if you have any questions, any clarification, please add them to the chat and let me know. So before participants started to endeavor through our study, which was about 10 minutes, they read what they'd be doing. So they read that they'd be taking 2 quizzes, an anagram and a trivia quiz. Then they read that depending on their performance, they might be eligible to participate in a team-based murder mystery task. And let me tell you, prolific participants and M-Turkers are like pretty excited that they might be able to work on a murder mystery task. They also read that 75% of all participants would be assigned the role of an applicant and 25% assigned the role of hiring manager, when in actuality, all of our participants were in the applicant role. Then after they took the anagram and trivia quizzes, they read about what their application to apply for this role on the murder mystery team would consist of. The application consists of not only the quiz scores, but how long they spent on these quizzes. So if they took the full 1 minute for each quiz, or if they were able to complete the quiz early, how difficult the answer was for the, how difficult the question was for those that they answered correctly. And they knew that they would also have the opportunity to write a very short essay, a 2-sentence essay, to include with their application. After this, participants then made the choice of if they wanted a person, another participant, or an algorithm to assess their application packet, which would determine their ability to join the murder mystery team. So we asked them how they wanted their application packet reviewed. And here, when given the choice between a person and an algorithm, 70% of people said that they wanted the algorithm. And this is significantly different from 50% or indifference between the two. Next, we wanted to see, might there be something about the application pool itself that could change people's really strong preference for a person to assess their performance when considering them for a role? So here in study 2, we randomly assigned people to either a low competition condition or a high competition condition so that we could test whether preference for the person might weaken when competition in the application pool itself is higher. So people either thought that they were applying for a spot on a team where there were only 5 other applicants or 21 other applicants. And here we find that when the competition is higher in the application pool, this preference for preparing a person to assess their application over an algorithm weakens. We didn't flip our effect, however, but this is a moderator that weakens the preference for the person. After this, we wanted to change our perspective and look at the role of how are people seeing the person who they're considering to have assessed their application packet. Are there characteristics of the hiring manager that might influence people's willingness to have a person versus an algorithm assess their performance? So we wanted to test if people prefer an algorithm when the hiring manager is a member of their outgroup. We used the same paradigm, but before people found out about the application packet, right after they took the 2 quizzes, they reported their thoughts, their beliefs on 3 hot button political issues. So we had minimum wage, gun ownership, and abortion. Then after that, they read about the information on the application and what that consisted of. And then they were told the person that you're deciding between, the person and the algorithm, either agrees with you on the issue you care most about or completely disagrees with you. So that's how we manipulated in-group versus out-group. We find here that when the hiring manager is a member of the in-group, people still prefer the person to an algorithm, but our preference in the participants switches when that hiring manager is seen as a member of the out-group. And I do want to say here, I don't have time to share all of the data we have, but we have some follow-up studies to suggest that the results for this study are actually due more to expectations that the out-group member is just incompetent or would have higher random error, rather than the out-group member being biased against them or having systematic error in their judgments and decisions. And so finally, we wanted to know, how good does an algorithm actually have to be before these applicants are open to using the algorithm? So here, we gave people either no information about the algorithm's past performance, or we told people that the algorithm, in putting together past teams, had a success rate where 60% of the teams successfully solved the murder mystery. Or people were randomly assigned to receive that information, but the number was 75% or 90% success. And so we find that even at 60% success or accuracy, people still are not preferring the algorithm to a person for who they want to hire them. The algorithm actually has to have been successful with putting together 75% of the past teams they put together as having successfully solved the murder mystery. So I think we're asking a lot for algorithms when we're applying for jobs and considering who we want to assess our performance. So in summary, people have a pretty strong preference for having a person review their past performance and their application packets when they're applying for a role on a team. This preference is quite strong, but it does weaken when competition in the applicant pool is higher, and it actually reverses when the hiring manager is a member of the outgroup member, is a member of the outgroup. And then finally, algorithms require 75% accuracy before applicants start to prefer it to a person. So thanks so much, and I'll stop sharing my slides so the next person can throw theirs up.
Excellent. Thanks, Jen. Really interesting. Okay, you got a lot of questions in the chat, so maybe you can look at those over the next talk. But I mean, I think people had some questions about what are some of the underlying psychological mechanisms for each of the different findings you had. And I'll just highlight Anav's question here. She was asking about, you know, could there be different perceptions going on in terms of could people think that algorithmic decisions are more fair but less in their favor sometimes? Like, could there be these dual perceptions that are happening?
Yeah, that's actually exactly why we wanted to test with the outgroup member of the hiring manager. Were those results driven more that people just saw the outgroup member as incompetent, or do they think they would be biased against? And there we found it was more just seeing that person as incompetent rather than thinking the person would be more unfair than the algorithm. But that's actually a path that we really want to try to figure out more. There's definitely more studies we are thinking of running related to that. These ideas of fairness, we ask in a lot of our studies, like, how fair do you think each source is? Do you think they're competent? And I think that there's these trade-offs between thinking that maybe you could persuade the person, but maybe less so the algorithm. And so we're hoping to dig more into that. And that's partly why we had included the essay task as to kind of look at that a little bit further. But there's still a lot more data that we need to analyze here.
Cool. Okay, well, I'll let you answer whatever questions in the chat that you want, and let's move on. So next we have Thea Tomova-Shakur, and she is at New York University, still a student there, but I think next year will probably be on the market. And Thea, I'll let you take it away. Thanks.
Thanks, Juliana. Can you all hear me and see my screen?
Yep.
Yeah, perfect. So hi, everyone. I'm Thea Tomova-Shakur. I'm a fifth-year PhD student at New York University. And today I'll present a project in collaboration with Professor Arthur Jago from University of Washington, Tacoma. As organizations increasingly rely on algorithms to make important organizational decisions, such as hiring decisions, as Jen just talked to us about, in this study, we explore how stakeholders perceive algorithms' capabilities to detect important information about job candidates, such as their diversity characteristics. Algorithms are very good and skilled at depicting different types of diversity characteristics. For instance, they can depict straightforward, less complex diversity information, such as surface level diversity characteristics, as well as more complex and nuanced diversity information, such as people's deep level diversity characteristics. Yet we know little about how stakeholders, such as job candidates or employees, perceive algorithms' capability to detect different types of diversity information. Generally, algorithms are perceived as poor depictors of contextual and idiosyncratic information, and people perceive them as more likely to omit key, unique evidence about their personal circumstances and situations. In the context of diversity, some diversity characteristics might be perceived as more unique than others. For instance, deep-level diversity characteristics are more complex and nuanced, as they vary along a multitude of dimensions and categories, whereas surface-level diversity characteristics are less complex and more straightforward, as they manifest in fewer areas and categories. Pilot data suggests that, in fact, deep-level diversity characteristics are perceived as more unique than surface-level characteristics. Based on this logic, we predict that people will perceive algorithms as less likely to depict and rely on unique diversity characteristics about job candidates, such as their deep-level diversity characteristics, compared to human recruiters, and they will be more likely to rely on straightforward diversity information about job candidates, such as their surface-level diversity characteristics, compared to a human recruiter. Further, we believe that these perceptions will be largely explained by the idea that algorithms neglect unique qualities in the first place. To test these hypotheses, we ran 5 pre-registered experiments, but in the purpose of this talk, I will only share results from 3 studies with you today. And without further ado, I'll jump straight into study 1, in which we randomly assigned individuals into either an algorithm or a human condition, in which we asked them to generate in an open-ended manner what characteristics they believe each recruiting agent will rely on when assessing the diversity of job candidates. To analyze their open-ended responses, we created our own LOGG dictionaries, which contained of 360 deep-level diversity characteristics and 116 surface-level diversity characteristics. From these open-ended data, we discovered that, as predicted, individuals perceived employee recruiters to be more likely to rely on unique diversity information about job candidates compared to algorithms, whereas algorithms were more likely to rely on straightforward diversity information, such as surface-level diversity characteristics, compared to employees. Learning from this open-ended rich data, we next employed a quantitative approach, and we surveyed about 170 working adults from a different country, from Bulgaria. And we asked them to share with us the extent to which they believe algorithms or employees will rely on 5 different deep level and 5 different surface level diversity characteristics. And this study employed a repeated measures design, so participants responded to questions about both algorithms and employees. Further, we also probed their perceptions about the uniqueness neglect of each recruiting agent. And we discovered that, again, as expected, individuals perceived employees to be more likely to rely on unique diversity information about job candidates, such as their deep level diversity characteristics compared to algorithms. But in this study, we found an unexpected effect in which employees were also perceived to be more likely to rely on less unique surface level diversity characteristics compared to algorithms. We have some thoughts why this might be, and we're more than happy to share them with you after this presentation or offline. But in the sake of time, I'll keep moving here. So next we tested whether individuals' perceptions about algorithms' inability to detect and rely on unique diversity characteristics, such as deep level diversity characteristics, was explained by the idea that algorithms neglect uniqueness in the first place. And we do find that uniqueness neglect mediated those perceptions. In the final 1 minute that I have left, I'll quickly talk to you about whether these perceptions are malleable. Lay people may not realize that modern algorithms may in fact detect complex and unique information about people. So we probed the idea that if we provide participants with accurate information that algorithms can in fact depict unique and complex information, would that bridge the gap between the perceived capacity of algorithms and humans to detect deep level diversity characteristics in the first place? So we designed an experiment which had a 2x2 design. Participants were randomly assigned into algorithm or an employee condition, and they were also randomly assigned into a control or information condition. In the information condition, we told participants that the recruiting agent can detect unique information to a great extent, and we gave examples from both media and social media advertisement and the medical field. And in the control condition, we simply talked about what the hiring process looks like. The rest of the measures were the same as in study 2, so I will skip through those and show you the results. So 2x2 ANOVA suggested that the gap between the perceived capability of algorithms and humans to detect deep level diversity characteristics attenuated for participants who were exposed to information about the agent's ability to detect unique characteristics in the first place compared to participants who were not exposed to such information. So given that these perceptions are quite malleable, organizations that plan to use algorithms as hiring agents should provide sufficient information to these stakeholders that these agents are in fact quite good at depicting complex and unique information. With that, thank you so much, and I'm looking forward to getting your questions and comments.
All right, thank you so much, Thea, for that. Very well done. And so a couple of thoughts. We have such wonderful conversation and questions going on in the chat, and also in interest of time, what we're going to do for the Q&A after each talk is we'll direct that to the chat, and then we'll just move on to the next talks, and then we'll have some time at the end for broader conversation. So with that said, attend to the chat for discussion. And then next up is Noah CASTELO, assistant professor at University of Alberta, talking about the AI invasion. So take it away, Noah.
All right, thank you very much. Thanks everyone for coming, and thanks for Nate and Juliana and Hannah for organizing. So I'll be talking about basically how students and employees respond to AI starting to be used in their workplace or in other workplaces. This is joint work with my colleague Gerald Heubel in marketing at the University of Alberta. So this work was partly motivated by the fact that there are these two very competing and sort of contradictory narratives in the media about the effects that AI will have on human employees. So you often see stories like these talking about how humans will be the beneficiaries of AI, will be able to collaborate. AI will make our jobs easier, more efficient. But then you also see the complete opposite narrative very frequently. AI is going to come in and take over all of our jobs and make it much harder for humans to succeed. So we were basically interested in, first of all, how do students and employees perceive this question? Do they perceive AI as more of a helper or more of a competitor in the workplace? And then what factors impact those perceptions of AI as helper versus competitor, and why might those factors be important? And then we'll look at how those perceptions of help versus competitor affect people's career preferences, what types of jobs and fields they're interested in pursuing themselves. So in the first study, we had a representative sample here in the United States, and we gave people a very brief introduction to the idea of AI being used in a growing number of fields, and we told them that it can perform tasks that humans now do. And we asked people 3 questions. So first of all, would you perceive an AI in the workplace as being more of a helper or competitor? Then we said, if AI was available in another field, would it make a job in that field more or less attractive? And then third, we asked people, if AI was available in your own job as a tool for you to use, how likely would you be to use it? And we asked people these questions 3 times. So first, in reference to an AI whose performance was ambiguous, so we didn't specify how well the AI could perform. And then again, we asked these same questions in reference to an AI that we described as performing at the level of the average human employee. And finally, a third time in reference to an AI that we said performed at the level of the very best human employee. And that was a within subjects factor. So first here, we'll look at the perceived role of AI as being more of a helper, more of a competitor. So the red curve here is the ambiguously performing AI. And we saw that a majority of people see it as much more of a helper in that case. So about 66% of this group saw an ambiguously performing AI as more of a helper than a competitor. But we saw that perception actually reverse when we're talking about a high performing AI. So an AI that can perform as well as the best human employee was seen as much more of a competitor than a helper, and the average performing AI falling right in the middle there. And then we see the same pattern when we look at this attractiveness of a job, attractiveness of a job in a field where AI is used. So an ambiguously performing AI makes a job in that field more attractive. High performing AI makes a job in that field less attractive, with average falling in between again. And then same pattern again with the likelihood of actually using an AI that's available to you. So I think this one's particularly interesting where you see high likelihood of using an ambiguously performing AI, significantly lower likelihood of using a high performing AI. And I think this is interesting because a lot of the psychology adoption literature emphasizes that the more useful technology is, the more high performing it is essentially, the more likely people will be to use it. That's kind of a fundamental finding. But here we're finding that actually a more high performing technology, people are saying they're less likely to use it. So in study 2, we wanted to look at whether this pattern generalizes to other forms of technologies as well as to human employees. So we asked people to consider that your workplace has either hired an additional employee to perform some of the tasks that you currently do, or that they've purchased a new AI software program, or that they've purchased a new productivity software program. And we asked people to consider that this entity, so person or software, had increased their office's productivity either by 5%, a small improvement, or 50%, a large improvement. And we asked people in this study just how much do you think this person or software would be a helper or a competitor to you? So we see a significant effect for all 3 entities of performance ability, such that moving from low to high performance makes the entity in question seem like more of a competitor. But we do see a significant interaction here, indicating that the effect is significantly larger for AI than for either human or productivity software. So study 3, we wanted to look at what is it about AI that makes it seem more threatening, more of a competitor when it's at this high performance level relative to other equally high performing technology. There are lots of explanations you could come up with. Here we're focusing on the idea that AI might be seen as more of a threat to people's competence and autonomy. So 2 of the fundamental human needs according to self-determination theory. So we had a similar design to the previous study, where we asked people to consider either AI or cloud computing software being used in an accounting firm. And we recruited business students from Prolific for this study, so the scenarios would be more relevant to them. And we asked them first, in terms of the psychological threat idea, how much they would agree with the statements that the use of either AI or cloud computing would make me feel less competent compared to doing the work alone, and would make me feel less able to think and decide for myself compared to doing the work alone. And then we also measured, again, perceptions of helper or competitor, interest in a job at a firm that uses the technology, and interest in accounting field in general. So as expected, we saw that AI is seen as more of a competitor than cloud computing. Similarly, people were more interested in a job at a firm that uses cloud computing compared to a firm that uses AI. We didn't see a significant effect on interest in accounting in general. It was more specific to the actual company that's using the technology. And then we do see that AI is posing or seen as posing significantly greater threat to competence and autonomy. And then these measures of psychological threat also predicted interest in interest in a job at a firm that uses the tech, as well as perceptions of the tech as being a helper or competitor. So some evidence that this idea of psychological threat is playing a role in distinguishing AI from other forms of high-performing technology. So last study I'll quickly share here was looking at how perceptions of the task or job itself might moderate any effect of AI entering that field. So we recruited undergraduate business students in this case and asked them to read one of two news articles. So these were real stories from Forbes, slightly shortened. So this was the first article talking about how AI is being used more and more in accounting, and it's posing a significant threat to humans because it's able to increasingly automate a lot of the accounting tasks that humans now do. So people read either this article or this control article about how you can book an Uber ride from an airport now without using a phone. So that was one factor we manipulated, sort of AI salience in accounting versus control. And then the second factor we manipulated was the perceived standardization of the task itself, of accounting. So we either highlighted that actually accounting is really repetitive, number focused, standardized. You're doing things like calculating taxes, analyzing spreadsheets. Or we emphasized that actually accounting can really have low standardization. So a lot of what you're going to do as an accountant is to work with clients, understanding their goals, coming up with creative accounting approaches and so on. So in this scenario, we expected AI to seem like it poses less of a threat, and that might change people's reactions to AI entering the field. And indeed, that's what we see. So when task standardization was high, we see this significant deterrent essentially of AI entering the field, making people less interested in accounting careers. Whereas when task standardization was low, we see no effect of learning that AI is entering the accounting field. So I think I heard the wine glass ding there. So I'll skip over the contributions except to say that I think the key finding here is there's this default perception when you don't talk about AI's performance, where people see it as more of a helper. But when people actually realize that AI can outperform a lot of humans, that perception reverses and it starts to be seen as much more of a competitor. So I'll wrap it up there, and thanks again for everyone's time and attention.
Thank you, Noah. Really interesting. You have a lot of questions in the chat. There was some conversation and debate going on even about like the labels that you use to describe AI and whether that can make a difference and how people are seeing it as a threat or not. So I'll let you kind of look through those. We are like massively behind time, unfortunately. So we are going to save all the rest of the questions to the end. We'll have like hopefully time for discussion at the end. So HATIM, why don't you go next? Thank you.
Awesome. Thanks so much. So my name's RAHMAN. I'm an assistant professor at Northwestern, and forewarning, I'm not a psychologist, so this is going to take a little bit of different flavor, and hopefully I'll add some nice variety to today's talks. But I will say that this project is spearheaded by David, who's a PhD candidate at Northwestern. He's a fourth year. So it was really nice to kind of join on and kind of share some of the thoughts from the study. So, you know, I think everyone is kind of, we've been talking about different algorithms. And this study, we're specifically looking at facial recognition algorithms. And as a lot of us know, in the context of organizations, governments, they're not just using people are not just using them to identify if someone is, you know, is somebody HATIM or not, but they're also being used to make decisions. Is somebody a leader? Are we going to hire them? What are their, how agreeable are they? Just based on the facial image that is presented to an algorithm. And of course, you know, we've seen troubling implications of its use kind of in the wild by police departments, organizations more broadly. And we know that the bias enters into these algorithms, but this study kind of goes a little bit deeper to look behind the black box, so to speak. And so one of the things that we kind of outline in this paper is that, you know, when you think about it, there's actually many types of bias that can enter each one of the modeling stages of an algorithm, right? and each one that's listed here that I won't get into detail here. We're going to focus on more of the algorithmic bias and interpretation bias, specifically focused on covariates. And so let me just give a brief example, just to a stylized example. So if you're training an algorithm to predict somebody's age, and if you were to give them pictures of elderly people who are wearing glasses, the algorithm would potentially pick up on this salient feature and use that to intuit that people who have glasses are likely to be older. And so we'd call this a transient feature, where whether someone chooses to wear glasses or not is transient, but wrinkles, other features of a face that are more stable would be more predictive. But again, the algorithm would pick up on this transient feature and kind of display a bias in that sense. And so the research question motivating this project is to more systematically evaluate the objectivity of decision-based facial recognition algorithms and really arrive at the question of are these algorithms actually using facial morphology and or the features of a face, and how are they being used? And so we're going to do this in the context of a leader detection facial recognition algorithm. So looking at looking at image, does it predict that you are a leader or not? And so the way we did this is we kind of use a more conservative test. And we collected images from the S&P 1000, so images of CEOs and CFOs, and as a comparison, also images of professors and actors. And when I mention it's a more conservative test, it's because we're collecting all very high quality images. So these aren't like kind of our, maybe on Facebook or Twitter where they're somewhat blurry. These are all very high quality images. And so for time, I'm going to skip over the details, but we're using what is probably the most widely used facial recognition algorithm called Face++. And there's a bunch of pre-processing that happens that extracts key information from the images, including 106 different dimensions that will tell you the attributes of a facial image in terms of the smiling, the head position, so on and so forth. And so in the paper, we kind of walk through how traditional approaches don't necessarily control or adequately account for the bias and covariates. So what we then next do is we use propensity score matching to match images in the different data sets so that the images are as similar as possible between the leader, actors, and the professors. And then we run a deep neural network before we did propensity score matching and after propensity score matching. And essentially what we'd expect to see is that, so again, I can't go into the details here, but the deep neural networks, they should filter out covariates. And that's a promise of them to being able to do so that we would see then that there should be no difference between the before and after matching performance using the deep neural networks. And so this is, again, there's a lot going on for a short talk here, but the difference is that you should pay attention to is that after matching, which is the green lines here, prediction actually decreased in both the pre-trained and the custom trained model. And so what that means is that the model is actually capitalizing on covariates. It's not ruling them out. It's actually using them in ways that aren't necessarily apparent to someone who's just interpreting the results. And so, again, credit to David here. He used adversarial machine learning, and what this means is try to identify what is the algorithm actually using to make its predictions. So, the way this works is that you kind of obscure more and more information from the algorithm to see what is being used. So essentially, in step 4 here, they're just going to be using the algorithm just essentially has the tip of someone's nose. And you see what does the algorithm do then? How well does it perform in each one of the sets? So, so yeah, each one of these, there's a different one, but kind of skipping ahead here, what you see here is that when people in the masking condition here, just to highlight, when you obscure more information from step 1 to step 2, the algorithm's accuracy is actually increasing. And you can see even in step 4, when you go back here, which is, most of the information, facial information is obscured, you still have, 3/4 of the time it's accurately predicting whether someone's a leader. And you see that also in the professor and actor group. Actually, in subsequent analysis, and I think I'm out of time here, what we found is that the algorithm's actually using background illumination and lighting and other transient features that are not actually part of the facial morphology of a picture to make these predictions. And so you can see that, again, they're actively capitalizing on covariates that aren't necessarily apparent to someone who is interpreting these results. So again, I'll kind of leave it here. I think I'm about 7 minutes, but we kind of introduced the term algorithmic face-ism, where an algorithm unfairly expresses inherent preferences for specific facial morphologies. And we kind of go into this that, in some cases you want covariates to influence your algorithm. In other instances, you want to control for them more carefully and know how they're being used within to make a decision. And I kind of conclusion is that, a lot more work needs to be done to understand when they should be used and when they should be, and at least have some understanding of what the algorithm is actually using to make these decisions. All right, and here's our email too. We have it if anyone wants to follow up with a draft of the paper or other questions.
Wonderful. Well, HATIM, thank you so much for that. That's very interesting talk. And so there's some questions in the chat that you can attend to, and with that we'll move to our last but not least talk, Mike Yeomans. So Mike, you want to jump in from Imperial College? So take it away.
Mike, you're muted. Oops. Your slides are fine. It's just that you're on mute.
Unmute. Can you hear me now?
Yep.
Yes, there you go.
Great. So sorry about that.
But by the way, now your slides look a little small. There we go. Yeah, perfect.
Okay. So thanks so much for the introduction and the keen assist there. HATIM, also, I really like your talk. It's a good lead into this one, as I was just saying on mute. So the first paper I ever wrote on algorithms focused on recommendations. And I think this is a fascinating domain, in part because almost everything we learn about the world comes from another person. And in the marketplace, people are constantly making recommendations to one another. And they've been doing so throughout most of human history. But in the last 20 years or so, a new kind of recommendation has emerged. There are algorithmic systems that can cheaply produce a mass quantity of personalized recommendations. So my co-authors and I wanted to see whether these recommender systems could approach the accuracy of recommendations for humans. So we ran one study in a museum where we recruited pairs of people who had come to the museum together. They all knew each other quite well already. They were spouses, family, friends, and so on. And we put these pairs in an experiment that felt like a fair test of how good they were at predicting their partner's preferences. So we used jokes as our preference domain in this paper. Jokes are short and personal, and I'm told that people tell each other jokes all the time. So we had people read and evaluate 12 jokes, and then we randomly grabbed 4 of those jokes as a sample set and showed those sample jokes to their partner. And then their partner tried to predict their ratings for the remaining 8 jokes, the test set. We also built a simple algorithm that's similar to a linear regression that used those same 4 sample jokes to make predictions for the 8 test jokes for every different person. So the results of this study were crystal clear. Humans did a pretty good job predicting their partner's joke preferences, better than chance, but the algorithm was much better. We ran another study with a similar design, and we replicated basically the same pattern. So again, the machines were outperforming the humans. But in this new study, we also let some of the human recommenders see the algorithm's prediction first before they made their own prediction. And these humans really weren't any better either. They weren't improving the algorithms, and they were barely even listening to the algorithms. So it seemed like there was a lack of trust. Another study we ran proves this point more directly. So here our main participants were receiving joke recommendations, and we randomized it so that sometimes they received a recommendation from an algorithm and sometimes from a human. But we also randomized it so that sometimes they thought it was from an algorithm. Sometimes they thought it was from a human. And afterwards, we asked them to evaluate how well they could understood what they thought the recommendations were about. So the results here showed a fascinating pattern of two separate main effects. So when participants felt they understood the recommendations, more when they thought it was from a human than when they thought it was from a machine. But when we analyzed it in terms of who was actually doing the work, it was the algorithm's actual recommendations that were better than the humans. And these differences drove our participants' choices at the end of the study. They said they would rather get a recommendation from a human than a machine because they thought they could understand the human recommendations better. So let me briefly recap the main highlights from that paper. Across 5 studies, when we tested accuracy, we found that recommender systems routinely outperformed humans, even close others like spouses. However, when we tested adoption, we found that humans were reluctant to trust algorithms. And we could mitigate this bias a bit by giving explanations that helps humans understand the algorithms a little better. Now, our work builds off a long line of research that shows that algorithmic interpretability is one of the key performance metrics for a lot of real-world algorithms, for recommender systems and all kinds of other domains. Furthermore, it's been well documented that humans have a lot of trouble understanding all kinds of less complicated technologies. So let me give you an example, a simple one, of the illusion of explanatory depth. So these are all drawings made by people who claimed they understood how a bicycle works. And if you ever see a real bicycle that looks like this, do not ride it. Not only do we routinely misunderstand machines, we routinely misunderstand each other. For example, it's remarkable how even in our most important relationships, simple misunderstandings can spiral into conflict. Now, most of my research these days focuses on using algorithms to understand natural language, and that's because language is the fundamental technology we have to make sense of one another. In that research, we found there's a powerful role for algorithms to improve our social sense making, and we analyze behavior to identify patterns of receptive language during conflict. But to actually change people's behavior, we need algorithms that are built to be interpretable. An interpretable algorithm can take what people say and highlight the choices that people make in conversation that could build better relationships. In these cases, I suspect that people aren't likely to trust a black box with their most personal behavior. Instead, to have an impact on social interactions, we're going to need to work even harder to explain and distill the wisdom in our data. So that's where I want to leave things today. Charting a path for 2 different important reasons for research on algorithmic interpretability. In private domains, I think we can work harder on the explanations we give for algorithms so that humans can understand these algorithms better. But when algorithms are used to modulate some of our most important and human experiences, then good explanations are absolutely essential. The dream is to build better, more understandable algorithms that help us be more understandable to each other. So thank you very much.
Woo, excellent. Okay, so thank you to all of the speakers. To no one's surprise at all, we were maybe a little overly ambitious in our time schedule, but we still have like a good half an hour for some in-depth discussion here. So first, Nate is putting together these breakout rooms for us, and the purpose of that is just to divide us into some smaller subsets in which we can have sort of more intimate conversation. So there will be speakers joining each of the rooms. You can see who they are on this slide here. So go ahead and change your participant name right now, if you haven't done it already, to add a 1, 2, or 3 somewhere in your name so that Nate can put you into the right breakout room. Okay, and if you want to really follow up with a specific speaker, like you really want to know more about Mike, what Mike said, then you know, make sure to put yourself into that room. Okay, everyone, welcome back. Nate, are you there?
I'm back, yes.
Okay, there he is. Okay, fantastic. Well, okay, so we're essentially just wrapping up here. I know you guys all need to go at 11:30. And Nate, I don't know about what happened in your room and Jake in your room, but in our room, we had a very wide-ranging discussion on tons of different topics, everything from like, what are the different psychological mechanisms underlying preference for algorithms to thinking about, you know, maybe trying to come up with a framework of where people might be getting it wrong in terms of their bias and algorithms. And so we are writing up notes on what happened in each of the breakout rooms, and we'll send out the really high level to all of you in a thank you email. And there'll also be a little survey link in that email that you all can take and tell us what you thought about this type of program.
Yep. Yeah, huge thank you to Jake and Hannah for helping with everything, and Heather and Jen for suggesting this. And so, you know, as Psych of Tech community, if you have any ideas or thoughts about what would be valuable for the research community, please let us know and we'll implement them, and we'll do them. So really appreciate all your time today, and looking forward to whatever comes next. So,
and thanks again to the speakers. Yes,
thank you so much.
Thank you, Juliana and Nate, for making this happen.
Yep.
Thank you.
Our pleasure. All right, see you guys next month, next Tech Talk.
Yep.
Bye.